Good morning, students. Today we are going with our next topic, that is the lattice energy. So what is lattice energy? Actually, if we are having we can say we are having any compound. Let's take the example of NaCl. We can take the example of KCl also. So for the formation of NaCl, we know that sodium as well as chlorine are there. Sodium atom, it will donate an electron. Or how it will donate electron? Because first of all, ionization enthalpy will be given to the sodium, due to which under the effect of this ionization energy, it will release the ion. But the atom must be in gaseous state. Okay, because it is not possible to release an electron from solid state, because it will require a very larger amount of energy. So we are releasing the electron from sodium by giving the ionization energy. Afterwards, let's think about the chlorine. What about chlorine? Chlorine, since it is a non-metal, so that's why since it is a non-metal, that's why it is not having the tendency to release the electron. That's why this electron, if we are adding in the chlorine, then the electron will get added and it forms chloride ion and releases a large amount of, I'm just writing it like this, releases a large amount of electron gain enthalpy. Okay, if it will be released in large amount, that means the ion will be more stable. So students, what happens when both these ions in their gaseous state combine with each other, then they form, these are in gaseous state and they form a solid crystal of NaCl, and this structure, it will be solid. So you can see that from the gaseous ions, you can see that the solid crystal of salt is formed. During this process, a large amount of energy is released, and this energy is called as lattice energy. So in this way, this is all about the lattice energy. This is about the lattice energy. So what is lattice energy? When when two, or means not two, we are just taking in 1 mole. So when 1 mole of any ionic compound is formed, or 1 mole ions are formed, or we can say when 1 mole any ionic compound is formed by its gaseous, cation and anion, then a large amount of energy is released, and this energy is called lattice energy, which is used for the formation of crystal lattice. So this is called the lattice energy. Okay, so this is about the lattice energy. Or if we have made 1 mole of ionic compound from these ions, so simply what we will do, if we will break this 1 mole ionic compound, then also the absorbed energy will be equivalent to the lattice energy. Generally, we are not having any parameters, any particular parameters for the calculation of lattice energy, because we are not able to calculate it properly. That's why we are having the Born-Haber cycle for the calculation of lattice energy. That is Born-Haber cycle. This cycle is used for calculation of amount of lattice energy released during the formation of the ionic compound. Okay. Before we start for the Born-Haber cycle, let's discuss about the different parameters or different type of energies. Like, what are the different type of energies? Like, you know that what is the ionization energy? The amount of energy which is used to convert, the amount of energy which is used to convert any solid atom into its ionic state. That is, we can say, to remove the electron, okay, from any atom. Second one, it is the electron gain enthalpy. that is electron gain enthalpy, we can write it like this, delta H Eg. So it is the energy released when gaseous anion is formed. Okay, when gaseous anion is formed. Next one are again the sublimation energy that we forget. Sublimation energy is the amount of energy which is required to convert the solid atom into the gaseous state. It is the sublimation energy. Okay. Next type of energy that we use, that is the dissociation energy. It is the dissociation energy. What is the dissociation energy? We can write it like this. Dissociation energy, that is the energy which is required to dissociate a molecule. Means the energy required to break a molecule. This is called the dissociation energy. Like if we are having the Cl2 molecule, so if we are dissociating or breaking the bond between both the atoms so that we can get a free ion or a free element, then it is called as dissociation energy. Like it is present in gaseous state and we are again converting it into gaseous, we get 2Cl. So this is the dissociation energy. Okay. One more energy is there, that is the heat of formation. So we can write it like this, delta HF. So what is the what is actually the heat of formation? So whenever any we can say that if we are preparing 1 mole compound, if we are preparing 1 mole compound, like we are preparing NaCl, that is 1 mole NaCl, then if we are preparing any we can say any compound, that is 1 mole compound, and the raw materials for preparing this compound are in their pure state, like sodium is solid because sodium actually act in solid state, and chlorine, it also act in, it's like chlorine is found in generally gaseous form and we are getting the solid. So for preparing any compound from the elements in the pure state, the amount of energy required, it is called the heat of formation. Generally the heat of formation is not required, it is actually released, because during the formation this amount of heat of formation, it is actually released. So you have to remember about the heat of formation. Okay. Now let's discuss about the Born-Haber cycle and lattice energy. I told you that lattice energy, that is the energy required to form an ionic compound, 1 mole ionic compound from their gaseous cation or anion. So these all energy terms we have to use during the Born-Haber cycle. Students, I will tell you the examples for the formation of Born-Haber cycle and you also have to practice for them. Now students, you can see about the Born-Haber cycle. तो Born-Haber cycle क्या होता है कि लैटिस एनर्जी को मेज़र करने का तरीका है. ठीक है, तो देखो हम कैसे मेज़र करेंगे. जैसे हम सबसे बेस्ट एग्जांपल लेते हैं. फर्स्ट एग्जांपल वी आर टेकिंग फॉर द फॉर्मेशन ऑफ NaCl. So for the formation of NaCl, we know Na plus Na and Cl2. They will combine with each other and form NaCl. So during the formation of NaCl from Na, मैं इसको हाफ ले लूँ because we are forming only 1 mole NaCl. So during this we know that delta HF, that is heat of formation, is released. So now we are going for the Born-Haber cycle. Now students, you can see देखो हम लोगों ने पढ़ा है कि सोडियम और क्लोरीन है, they get combined to form NaCl. Sodium is present in solid form, chlorine is present in gaseous form, and NaCl, it is also found in the solid form. During this process in pure state, the heat of formation will be released. तो इस तरह से हमें एनर्जी को निकालना बहुत ही ज़्यादा क्या होगा, मुश्किल होगा. ठीक है, because both the means form are present in their we can say that is they are present in their pure state. To calculate the lattice energy, we will consider all the different type of energies. So let's start. Students, you can see that since if we are forming directly NaCl from Na and Cl2 in their pure state, then delta HF will be released. We will calculate the value of this delta HF, okay, and afterwards by using the different values of energy we can easily calculate the value of lattice energy. So how can we calculate? Let's see. Since sodium is there, there is another way to form NaCl. Like we can make it directly or we can make it indirectly. How can we make it in a indirect way? Let's discuss. So for forming this in indirect way, what will we do? First of all, Na is in solid state. So हम क्या करेंगे? इसको गैशियस स्टेट में कन्वर्ट करने के लिए हम इसको प्रोवाइड करेंगे सब्लिमेशन एनर्जी. ये Na किस में हो गया? अब गैशियस स्टेट में. ओके, नाउ व्हाट विल वी डू? अब हमारे पास में जब गैशियस स्टेट में सोडियम आ जाएगा तो वी हैव टू कन्वर्ट इट इनटू द आयनिक स्टेट. इसके लिए गैशियस स्टेट से हम आसानी से आयन निकाल सकते हैं, एक इलेक्ट्रॉन निकाल सकते हैं एंड वी कैन फॉर्म द आयन. ये जो एनर्जी रिक्वायर्ड होती है, दिस एनर्जी इज कॉल्ड द आयोनाइजेशन एनर्जी. एंड सिंस वी नो दैट ionization energy is actually absorbed by the Na, so it will be positive. So ये आ गई हमारे पास में क्या? Na प्लस. और ये किस स्टेट में आ गया बच्चों? ये हमारे पास में आ गया गैशियस स्टेट में. तो हम इसके साथ साथ लिख भी लेते हैं. ये क्या है? सब्लिमेशन एनर्जी पॉजिटिव, ये भी पॉजिटिव. पॉजिटिव हियर किसको इंडिकेट कर रहा है? दैट एनर्जी इज एब्सॉर्ब्ड. ओके, नाउ नेक्स्ट लेट्स कम टू द क्लोरीन. सो क्लोरीन का मॉलिक्यूल है, हमें एक एटम चाहिए या एक मॉलिक्यूल को डिसोशिएट करने के लिए फर्स्ट ऑफ ऑल वी विल रिक्वायर द डिसोशिएशन एनर्जी. ठीक है, और देखो बच्चों एक चीज़ ये है दैट यू हैव टू रिमेंबर, इफ़ द मॉलिक्यूल लाइक इट इज़ प्रेजेंट इन Cl2 state, so we require the dissociation energy, that's why it will convert into 2Cl atoms. But here if half molecule is there, means from this molecule, for half molecule, for one molecule dissociation energy will be dE. If we are representing here half mole or half molecule, then we also require the half amount of energy. So we can write it like this, that dissociation energy upon 2. हाँ दीदी, the value of dissociation energy will be positive, okay, because it is given, it is required by the molecule to get breakdown, and afterwards we know that we are getting the Cl, that is a gaseous atom. अब इस gaseous atom को वापस से convert करने के लिए, किस में convert करने के लिए? because we want to make an anion. तो हम यहाँ पे क्या मतलब whenever we are adding the electron to the chlorine, that is we are adding the electron. So that's why on adding electron we know that electron gain enthalpy, that is delta Heg, it will be released. So its value will be negative and we will get the Cl negative, that is gaseous anion. Now we know that if both the anions are combined with each other, like we are having sodium ion, we are having the chlorine ion, if we are combining both the anions with each other, then we know on combining a large amount of energy is released, that is lattice energy. It is releasing, that's why I am just writing over here negative. And afterwards what form? NaCl. Solid NaCl will be formed.